Question 11. Find all horizontal asymptotes of the function y equals x squared minus 4x plus 1 all over x squared plus 1 and justify your answer. All right, I saw many people in this problem earlier actually taking a really long route. I think you were finding the derivative and maybe looking for a horizontal tangent line, but a horizontal asymptote is simply finding the limit as x approaches infinity. So if I'm going to find the limit as x approaches infinity, I'm going to be comparing the degrees in the numerator and denominator. So since my degrees in the numerator and denominator are the same, I'm going to take the ratio of the leading coefficients, which would be 1. So my limit as x approaches infinity is 1, which means my horizontal asymptote is y equals 1. And it did say to justify your answer, y equals 1 is a horizontal asymptote, and that simply is because the limit as x approaches infinity equals 1. Please be very careful on your justification on this one. It is not a horizontal asymptote because the degrees are the same. So we take the ratio of the leading coefficients. We do that to find the limit as x approaches infinity. So you have to include in your explanation the limit as x approaches infinity. Right, number 12 and 13. Let f be a function defined on the closed interval -2 to 5. The graph of f prime, the derivative of f, is shown below. All right, number 12, find the x-coordinate of each relative minimum on the graph of f on the open interval -2 to 5. Justify your answer. So if I'm talking about minimums, I know that I'm going to make an f prime chart. So if this is f prime, and I'm drawing an f prime chart, I'm going to be looking at above and below the x-axis. F prime is negative or below the x-axis until I get to 1, and then it is above the x-axis after that. So that's what my f prime chart would look like. This does say where is there a relative minimum. Actually, this is actually occurring at 0, not at 1, sorry about that. There is a relative minimum at x equals 0, and that is because f prime changes from negative to positive. All right, if this would have changed from positive to negative, that would have been a maximum. All right, then the next question is, on what intervals, if any, is f concave up? If I'm talking about concavity, I'm talking about f double prime. So I'm going to make myself an f double prime chart. When I'm making an f double prime chart, since I'm going from f prime to f double prime, I will be looking at the slopes. So the slopes are negative, or the graph is going down until I get to -2. And then the graph is going up, or the slopes are positive until I get to +2. And then the slopes are negative, or the graph is going down after 2. So that's what my f double prime chart would look like. And then I would simply like to know where's f concave up. So it is concave up between -2 and 2. And that is because f double prime is positive. Right, question 14. Evaluate the integral from 1 to 4 of 1 minus 2 square root of x dx. All right, I'm going to rewrite this problem as 1 minus 2x to the 1/2. And now from here, we're just going to apply our integral rules. The integral of 1 will be x, and then the integral of this will be 2 times the raising 1/2 by 1 will be x to the 3/2, and then we multiply by the reciprocal on the outside, which will be 2/3. And then just simplifying that a little bit, I'll get x minus 4/3 x to the 3/2, and then I get to evaluate it at 4 and 1. So let's do this. All right, so if I evaluate it at 4, I'm going to get 4 minus, if I plug 4 in here, 4 to the 3/2, let's do the square root first. So the square root of 4 is 2, 2 to the 3rd power is 8, 8 times 4/3 is 32/3, and then minus, plugging in 1, I'm going to get 1 minus 1 to the 3/2 will be 1 times 4/3 is 4/3. All right, so now from here, it's just simplifying. I'm going to make this 12/3. So 12/3 minus 32/3 is going to be -20/3. And then minus, make this 3/3. 3/3 minus 4/3 is -1/3. So that will change to that. And then if I simplify that, I will get -19/3 as my answer. Okay, problem 15. Evaluate the integral of -3 secant squared x. One thing that you might want to do first is bump that -3 out front. And if you know your formulas, this is going to be a super simple problem. What I'm going to do on this one is simply the integral of secant squared is tangent x. Just bring my -3 down, and then remember to put my plus c, and that is it.